You're welcome back to my YouTube channel, and in today's video we are going to solve another question on the auto cycle series which we talked about in our last session. So now this question here, it says an engine operates on the air standard auto cycle. The conditions at the start of compression are 27 degrees Celsius and 100 kilopascals. The heat added is 1840 kilojoules per Kelvin. The compression ratio is 8 and determine the temperature and pressure at each point in the cycle. The thermal efficiency and the mean effective pressure, which is a question that we are asked to find. So the first thing that we need to do whenever we see a question like this is to get our PV diagram. We might not be able to get all the formulas in our head at once, but if we can get our PV diagram, we can be able to deduce one or two if we understand how diagrams work. So now let's start with the question. Now the first thing that it gives us, we write out our unit out. It said the conditions at the start of compression, that means at point 1 year, that is where the compression starts from. At 1 year, the condition at 1 year, we have the temperature should be 27 degrees Celsius. Therefore, T1 is 27 degrees Celsius, and we have our P1 to be 100 kilopascals. So we can go on to write, uh, we can go on to, yeah, we can go on to write about that. So we write our temperature, T1 is equals to 27 degrees Celsius, so that is 27. But now, since we have to deal with the normal units, we have to convert it to Kelvin, so we just add plus 273 plus 273. So if we add this together, 27 plus 273 is going to give us this will be 300 Kelvin. 300 Kelvin. 300 Kelvin. So now that is the value for T1, and then we already have our P1 to be 100 kilopascals over here. So we can write that also, our P1 to be equals to 100 kilopascals. That is, and kilo, we know kilo is equals to 10 raised to power 3. So we just keep that in mind. And now they say that our compression ratio is 8. So our compression ratio now is 8. We have our compression ratio. Yeah, I think it's compression V. Our compression ratio V is equals to 8, and we know our compression ratio is equals to V1 over V2, so let's just keep that in mind. So now, how do we go on to solve our question? Now, for us to be able to get any value at this point 2, the process from 1 to 2 is an isentropic process. So the what we are going to be using is PV raised to power constant is equals PV raised to power gamma is equals to C. So that's the formula that we're going to be using. So for if we use this formula here, PV raised to power gamma is equals to C. Now that is the formula that we're going to use, and this formula entails that P1 V1 raised to power gamma is equals to P2 V2 raised to power gamma. So that is the formula that we are going to use, and now we can now make P2 the subject of the formula because we have our P1 and we have our V1 over V2. So therefore if we make P2 the subject of the formula, we are going to be having P2 to be equals to P1 times V1 over V2, right? That is, if we divide both sides by V2. So therefore, V1 over V2, we know it as the compression ratio of, that is this compression ratio, this, that is this raised to power the value of gamma. So that is it for that. So now we know our value for P1, we know our value for compression ratio, and the constant up here is equals to 1.4 is a constant. So we just need to take note of that. So there, let us continue with our calculation. Now we know that our P1 is 100 kilopascals and our compression ratio here is 8. So therefore we just put it into that. We have this is equals to 100. We can decide to put the kilopascals times 10 to power 3, but we might not need that because P2 will also put it in kilopascals. Then we have times 8 close brackets raised to power 1.4 raised to power 1.4. So that is it for that. Raised to power 1.4, and then if we multiply this together, this is going to give us 1837.92. So equals to 1837.92. So now the 1837.92, and the unit, let's not forget the unit. The unit is kilopascals. The unit is in kilopascals. So now that is it for that. And now we have gotten our value for P2. So we are advancing more over there. So now what another thing that we need to get is our value for T2. And there is also this process whereby we have V1 over T1 is V1 T1 is equals to constant. So we are using the second formula here, which is we are using the second formula here, which is V1, yeah, no, it's more like T1 V1 T1 V1. Now this V1 will be raised to power gamma minus 1. Yeah, this is going to be equal to T2. Then we have our V2 raised to power gamma minus 1. V2 raised to power gamma minus 1. So now that is going to be our formula. So therefore, if we try to make T2 the subject of the formula, because from the question that we have over here, we are giving our T1, we are going to do it the same way. So if we divide both sides by T2, let me just put it here. We divide both sides by V2, so we are going to be having T2 here, like making T2 the subject of the formula, would be equals to T1. Then we would have V1 over V2 raised to power gamma minus 1. V1 over V2 is known as our the compression ratio. So that is the compression ratio of V raised to power gamma minus 1. So now that is it for that. So now we know our value for this from the question here. We know our value for this, that we know our T1 is equals to 300 Kelvin and our compression ratio is equals to 8 from here. So we can just come back to our question here and impute the formulas. So we have, since T2 is equals to T1 times this, we just impute, and therefore this is equals to, what is our T1? 300 Kelvin. So we write 300 Kelvin. into brackets. Then we have our compression ratio to be 8, 8 raised to power 1.4 minus 1, 1.4 minus 1, 1.4 minus 1. So now that is our formula. So if we solve this, you can punch this into your calculator. So if we solve this, we are going to be getting, this is equal to 689.22. 689.22. So, and let's not forget our units. Our unit is in Kelvin. So therefore, now we have gotten our value for P1, V1. We have gotten our value for P1. We have gotten our value for um, T1, which is given in the question. And now we have derived our value for P2, 1837.92 kilopascals. We have derived our value for T2, which is 689.22 Kelvin. So that is it for that. And now, what do we need to get again? We can decide, what we can try to get is, we need to get our next value, which is our T3. Yeah, we need to get for our T3, we need to get for our P3, T4, and our P4. So now let's look which processes can we be able to use to get the value for our T3 over here. That is from point 2 to 3. Now, from point 2 to 3 is a different process which is going to require different formulas. We cannot use the same formulas we use from 1 to 2 for 2 to 3, because from 2 to 3 is isochoric, while from 1 to 2 is isentropic. So now from 2 to 3, now we can decide to use the P over T formula, whereby we have P2 over T2 is equals to P3 over T3. But now we do not have both the value for the third pressure, which is the maximum pressure, and the third temperature. So we can only resort to back to the question here, whereby they gave us our heat here to be 1840 kilojoules per Kelvin. I don't think I wrote it. So they give us our heat added to be 1840 kilojoules per Kelvin. And for we know over here that heat is being added at this point here. Heat is being added at this point. This is where the heat is being added from. We know that. So therefore the heat is going to um be able to help us get our value for T3, so that we can be able to use the formula P over T equals to constant. So now let us check what is the formula for the heat added. The formula for the heat added, formula for the Q in the formula for heat Q in is equals to M times CV into brackets T3 minus T2. And this formula, I've talked about it in our former class, in our former videos. So now this is the formula over here, and now we are just going to be calculating the heat per mass added. We are going to assume that the mass is 1, and our CV, we know our CV is a constant, which is 0.718, which is something normally used. Our CV is a constant 0.718, so we can just impute these values here. We have uh, we have 1840, which is our heat added, 1840, the kilojoules per Kelvin is equal to, mass is 1, then our CV is 0.718. 0.718. When we open our brackets, we have our T3. We do not know the value for our T3. So this is our T3 minus our T2. Our T2 is what we got here at 689.22 Kelvin. So we write that there, 689.22 Kelvin. 22 Kelvin. Yeah, 22 Kelvin. So that is it for that. And now, so from here we know that we can just make T3 the subject of the formula. We will just make T3 the subject of the formula. First of all, 0.718 will multiply both sides. So therefore, we are going to be having this. This is equals to 0.718 T3 T T3 T3, then we have minus 0.718 multiplied by 689.22. So if we put 0.718 multiplied by 0. 0.718 multiplied by 0.22. So we can try to check that in our calculator. Yeah, 0.718 multiplied by 6 689.22, we get 494.86. So therefore we can mark this as 494 194.86. Now, since now we have gotten our value for this, we can just make 0.718 the subject of the formula. So we are going to be having 1840 1840, then this our minus 484.86, it will become plus on this other side. So we have plus 494.86. Now this is going to be equal to, it is going to be equals to 0.718 T3. So 0.718 T3. So now if we finish our calculation for this and we added this together, divide by 0.718, at the end of the day, let's do our calculation. We are going to get our value for T3 to be equals to, we are going to get our value for T3 is equals to 3251.89 Kelvin. 2351.89 Kelvin. That is the value that we are going to get if we finish this and get our value for T3. So now we have gotten our value for T3. We need to get our value for P3, that is the third pressure at this highest point at this highest point over here. So, and I have mentioned the formula that we're going to use earlier, which is P over T is equals to C. So now that is P2 T2 is equals to P3 T3. Let's do that. We have P2, we have P2 over T2 is equals to P3 over T3, and that is the formula that we are going to use. So now we have our value for P2, we have our value for T2, and we have our value for T3. So therefore we are just going to use this value here and make P3 the subject of the formula. So therefore we have our P3 is equals to P2 times T2 times T3 over T2. So we have P3, our P3 is equals to T3 P2 times T2 over um times no, it's more like times T3 over T2 times T3 times T3 over T2. So now this is the formula that we are going to be using over here. P3 is equals to P2 times T3 over T2. So now if we use this formula here, we have our value for P2 to be we got our value for P2 here to be 1837.92, and we have our value for T2 to be 689.22. We have our value for T3 to be 3251.89. So you just impute those values into here. Yeah, this is equals to our value for P2, which is 1837 1837.92 0.92, yeah, and that is for the pressure. And now multiplied by the value for T3 divided by T2. So multiplied by what is our T3? Our T3 is 3251.89. We have 3251. We have 251.89, 251.89 divided by 689.22. We have 689.22. 699.22, then we close our bracket. So if we finish this calculation over here, 1837.92 multiplied by 3251.89 divided by 689.22, we are going to get our value for P3 to be 8671.71 kilopascals. So we're going to get our value as equals to 8671 0.71 kilopascals. So that is going to be our value for P3 over here. Now we've gotten our value for P3, we need to get our value for P4. We have our value for 1, 2, 3, and we have our value for P4. Now we know for the relationship from 4 to 3 is usually is an isentropic relationship. The relationship from 4 to 3 is an isentropic relationship. Therefore, we can use our formulas, which is PV raised to power gamma is equals to C, and we also have the second formula, which is V1 T1 V1 raised power gamma minus 1 is equals to V2 T2 raised power gamma minus 1. So those are the formulas that we are going to be using for this. So now let us move on to what we need to get first, which is our let's use our P4. Let's use our P3 to get our value for P4. So now we have our P4. Our P4 P4 now our P4, then we have V4 raised to power gamma is equal to our P3 our P3 V3 raised to power gamma, and that is our formula here. So what we just need to do is to make our P4 the subject of the formula. So now if we make our P4 the subject of the formula, we are going to be having P4 is equals to P3 into brackets. P3 into brackets, we have V3 over V4 over V4 over V4 all raised to power gamma. So that is how it's going to be. So now, what is our V3 over V4? We do not know, but we can be able to relate our V3 over V4 into compression ratio somehow. So now let us check what our V3 over V4 is. So now we know our compression ratio is equal to V1 over V2, and we know V1 is the same thing as V4 and V2 is the same thing as V3. So our V1 over V2 is the same thing as V4 over V3. So now in this place, it is saying V3 over V4. V3 over V4 is therefore going to be the inverse of the compression ratio. That is, if we do 1 over V4 over V3, we are going to get V3 over V4. So if we do the inverse of the compression ratio, this is going to give us something. This is going to be equals to P3 P3, then we have into our brackets, we are going to be having 1 over the compression ratio, here, close the brackets, then we have raised to power our value for gamma, and this is going to be the formula that we are going to be using to solve this question here. So now we are finding for our value for P4, we have our value for P3. Our value for P3 here is 8,671.71 kilopascals. So that is our value for P3, and then we have our value for compression ratio, which is 8, and then the gamma constant here, which is 1.4. So we just input our values. We have this is equals to 8,671 kilo.71 here. Then we have into brackets 1 over 8 close brackets raised to power 1.4. 1.4. So we can finish this. You can punch this into your calculator. We are going to get our final answer to be equal to 471.84 kilopascals. 471.84 kilopascals. Yeah, and so that is the how we are going to solve that. And so now we have gotten our value for P4. We can continue to get our value for T4, that is our fourth temperature. So now we have T4. We are going to use that same formula, which is Vt is equals to constant, whereby we have the V is raised to power gamma minus 1. So if we use that formula, let's not go to the entire this thing. So let's so we have our T4. If we use that formula, we're going to be having T4 is equals to T3 T3 into brackets V3 V3 yeah V3 over V4 close brackets raised power gamma minus 1. So we have gamma minus 1. So therefore, this is going to be what the formula is going to give us after we finish summarizing it. So we just impute the value for T3 to be equals to, we have our T3, yeah, our T3, instead of writing T3, let's just put the values once. Our T3 now is equals to what we got here. Our T3 is what we got here to be 3251.89 Kelvin. So we write our value here 3251.89 Kelvin. Then we open our brackets. We have 1 over the compression ratio, then close our bracket, raised to power, then we have 1.4 minus 1. We have 1.4 minus 1. So now that is what we are going to be solving from here. And if we find for the answer for this, if you put it into your calculator, you are going to get 1415.47 Kelvin. So now we have gotten all our values in the first question, which they asked us over here, which is that they asked us to determine the temperature and pressure at each point in the circle. We have successfully gotten that. So now we are going to be solving for our thermal efficiency and our mean effective pressure.